Today we'll be looking into laws of indices. Laws of indices. Now, what are indices? Indices are known as powers or exponents. They are known as powers or exponents, and in mathematics we can say they are base number written alongside a superscript number. A base number written alongside a superscript number. For example, um, if you have a times a times a times, that's what? Count it. 1, 2, 3, 4. That's a raised to power 4. In indices, this is the base, and this is the power or index, or you can even call it exponent. Now, basically, this is what we'll be working with, just for you to understand the basics of what is called indices. Now, from this value here, a raised to power 4, this is the a is the base, while the 4 is the is called power, index, or exponent, because the 4 is a superscript number. Now let's go into the law of indices in full. Now from the screen, you see 7 laws written and some notes. These are the basic things you need when it comes to simplification evaluation in indices, when it comes to calculation in indices. Now let's start with law 1. Law 1 says a raised to power m times a raised to power n is equal to a raised to power m plus n. In indices, when you have two base number with superscript, maybe you have a base number, you're multiplying two bases together, and they both carry superscript. For the law to be effective, the base must be the same. The bases must be the same. This is a raised to power m here, this is a raised to power n here. Now a raised to power m times a raised to power n will equally give us a raised to power n plus n. Let's look at an example here. For example, if you have 2 raised to power 2 times 2 raised to power 3. Now this 2 raised to power 2, we can also say it is 2 times 2 times this 2 raised to power 3. It means multiplying 2 in 3 places times 2. Now from here, instead of going through all these processes, you can as well use the law of indices, the first law of indices, which is 2 raised to power 2 plus 3, and that will give us 2 raised to power 5. And 2 raised to power 5 is equally this, which is 2 times 2 times 2 times 2 times 2 times 2, and that will give us what? 32. Now the law of indices covers this. Instead of going through this long process, you use your first law, that anytime you are multiplying a value with base and superscript with another value with base and superscript, once the bases are the same, you can use the first law of indices. Now let's go to the second law. The second law says a raised to power m. This is the second law on screen. A raised to power m divided by a raised to power n will give us a raised to power m minus n. That's another law, law 2 of indices. Now this simple one, this one is also what makes it different. The difference between the first law and the second law is this division here. Now anytime you have two values or two indices dividing themselves, having the same base, then you make use of the second law. That's a raised to power m minus n. Let me give you an example on this. For example, on law 2, maybe you have 2 raised to power 4 divided by 2 raised to power 2. Now, equally, when you see this, you know, okay, I can also work it out like this. 2 times 2 times 2 times 2 over 2 times 2. And that will give us what? 2 times 2 times 2 times 2 is 16. 2 times 2 is 4. Is 4. Now, 16 divided by 4 is what? 4, basically. But when you use the law of indices, you can as well say, okay, from the law of indices, the bases must be the same. We have 2 here, 2 here, the bases are the same. Then you have 2 raised to power 4 minus 2. And that will give us 2 raised to power 2. And that will give us what? 4. Now, are you getting? Now, that's law 2 on the second law of indices. That's when it comes to law of addition. That's law 1. When both powers when you are adding both powers together. Law 2, when you are subtracting the powers. That's when the two indices question is dividing each other. Now, this is law 2. Now, let's go to law 3. Law 3 says when you have a raised to power x, open bracket, a raised to power x, close bracket, raised to power y, then what will be the value we are getting from this? What value are we going to get from this if we have that? Now, if we have this, equally, you multiply the powers together, opening the brackets, holding the index. Now, this is a raised to power x in brackets. Now, raised to power y again. Now, how am I going to do this? You remove your bracket and it becomes a raised to power. You multiply the bracket and the indices, those powers together, x and y. Then it becomes a raised to power x times y. And that equally gives us a raised to power x, y. Now, let's quickly do an example on this too. Law 3. Law 3. Law 3. For example, when you have 2 raised to power 2, 2 in bracket raised to power 3. Now, this can, on a norm, this can equally be 2 times 2 raised to power 3. 2 times 2 raised to power 3. Then law of indices says, okay, when you have this 2 raised to power 2, multiply the indices or multiply the powers together. Now, when you use law of indices here, you have 2 raised to power 2 times 3, and that's 2 raised to power 6. Then what is 2 raised to power 6? 2 raised to power 6 is 2 times 2 times 2 times 2 times 2 times 2, and that is 2 times 2 4, 4 times 2 8, 8 times 2 16, 16 times 2 32, 32 times 2, that's 64. 64. But if you equally use this method, 2 times 2 is 4, 4 raised to power 3, then you have 4 times 4 times 4. That's got to what? Still 64. That's on law 3. Now, instead of going through all these processes, you can as well use the third law of indices that says you multiply the powers together when you have something like this. Now, then you have 2 raised to power 2 times in bracket raised to power 3. You multiply the powers together, 2 times 3, that's 6, and you get your final answer. Now, let's go to fourth law of indices. The fourth law of indices says when you have a raised to power 0 is equal to 1. This is also known as the zero index. The zero index. Now, this is not only applicable to A. Okay, the reason why I'm using A in the law, the reason why I used A all through is because I just picked that value, that A as a value, standing in gap of other values. Now, you can, this one, the law 4 says A raised to power 0 is equal to 1, which means 2 raised to power 0 is equal to 1. Anything, any numbers raised to power 0 will equally give us 1. Now, this you should have in your mind. Any power raised to power 0 is equal to 1. Now, we can have, okay, here we can have 2 raised to power 0 is equal to 1. We can have 3 raised to power 0 is equal to 1. Now, that's on zero index, law 4. Now, let's go to law 5. Law 5 says a raised to power minus m. That is law of negative index. Law of negative index. That's law 5. Now, it said a raised to power minus m is equal to 1. This is it. When you have a raised to power minus m, or you have any number raised to power minus carrying a negative index, what will happen? The negative here is standing for, it means inverse, or I can say division. Now, because of the negative here, your a raised to power minus m becomes 1 over a raised to power m. A raised to power minus m is equal to 1 over a raised to power m. For example, if you have, let me do an example here. If you have, let me go to law 5. Law 5. For example, if you have 9 minus 2, 9 raised to power minus 2, 9 raised to power minus 2. This is an example, a typical example. What will happen to this? What are you going to get out of this? Now, you have to, it will be is equal to, since it's a law of negative index, law 5, the minus will cause an effect, and that effect is that it will turn the 9 raised to power 2 into 1, or 9 raised to power minus 2 into 1 over 9 raised to power 2, and that will be 1 over 9 raised to power 2. Then your final answer will be 1 over 9 times 9 is what? 9 times 9, and that will be 1 over 81. Now, on that, when you have law, when you have a value that looks like this, law 5, a raised to power minus m, then it's a law of negative index. That's 1, that becomes 1 over a raised to power m. Now, let's go to law 6. Law 6. Law 6. Law 6 says when you have, this is law of fractional index. Both law 6 and law 7 are the same, but one way I have to split it because I want us to understand some things. Then now, when you have a raised power 1 over m, the power is fraction. This is law of fractional index. The power or index is fraction. The superscript is fraction. Now it becomes root 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 a. The m here will be the numbers of times the numbers of times a number that when you multiply in this value, when you multiply in this value will give us a. I will explain what I mean. Now let's go to law 6. Law 6 plus 6. Example, let me use 9, 1 over 2. Now, 9, 1 over 2. This will give us what? What will this give you? This will give us 9, 9. Then the 2 will be here. The 2 is not outside here. The 2 is not outside there. The 2 is in between the roots. What does this mean? It means that you look for a factor or a number that when you multiply twice, it will give you 9. That's square root. I simplify this because sometimes you may have it to be 3, 4, 5. If it is 4 here, you put 4 here. Then you find a number that when you multiply 4 times, you find a factor when you multiply 4 times, you get 9. If it is 3, you put your 3. You find a number when you multiply 3 times, you get 9. But here we have 2 here, which means you find a number when you multiply 2 times, you get what? You get your 9. And that is what? The factor is what? 3. When you multiply 3 2 times, 3 times 3 will give you 9. Then this to means this is what? Square root of 9. This fraction here, the denominator will take the root. The denominator will take the what? The root. Now, understand it. Now, the denominator will take the root. That's how you will go about law 6. Now, anytime you have a fractional index that has 1 over whatsoever value it is, you find the square root, you find the root of what? Of the number in relative to the denominator. Now, let's go to law 7. Law 7. Law 7. Law 7. Law 7 is somehow similar to law 6. We are still on fractional index. But the reason why I put this law 7 is because so it will not be confusing. This one in law 6, this one will not be of any effect, but it's also equally taking a shape of raising to power 1. Then this 3 raised to power 1 is what? Is still what? Is still 3. But in law 7 will explain, will open our eyes better to what I'm trying to say. Now, this is law 7. When you have a raised to power x over y, this is still fraction. Now, it will take a shape of a raised to power 1 over y, and turn your x to, you bring your x out, then it becomes root of a relative to y raised to power x. Raised to power x. Now, let me give you a typical example. Now, I'll still use 9. Maybe you have, okay, let me use 27. Maybe you have 27 raised to power 2 over 3. 27 raised to power 2 over 3. Then, how do you break this down? Using the law of indices. This is just how you break it down. Now, this will become, there are some, you can have your various ways you solve mathematics. Mathematics, I may know a method of solving, you may have another method, but meanwhile we still arrive at the same answer. Using this, I can solve this using like 2 laws here, using different methods, but just follow what I'm saying based on law 7. Now here, what are we going to do? This will result into your denominator. Your denominator will be here. Now get it very well. Then you put your 27 here. Then this will become raised to power the numerator 2. Now, this becomes cube root of 27 raised to power 2. But what is cube root of 27? What cube root means is, what's a number that you will multiply 3 times that will give you 27? You can find 27 prime factor. You can look for the factors of 27 to get your answer. But if you are smart to that extent, you should be able to know the answer straight from here. Now, what is the number you have that when you multiply 3 times you get 27? That is what? That is 3. Don't forget you still have your what? Raised to power 2, your numerator hanging here as a power. Then that will become raised to power 2. Raised to power 2. That's 3 raised to power 3. 3 times 3, and that will equally give us 9. 9. And that is how you look into all the laws, law 1 to law 7. But I gave some other notes here. This will be of help when it comes to indices and solving. There are some cases whereby you have this ab raised to power x. You see that this is two different bases having the same superscript index. Now, how do you go about it? You split it, a raised to power x times b raised to power x. For example, when you have 2 times 3 raised to power 2, that will give us 2 raised to power 2 times 3 raised to power 2. This can as well be 6 raised to power 2, right? And you have your 36. Your 36. Also, this is 4 times 9, and that will give us what? 36. Now, equally for the second value, second note, that's when you have their division. Maybe you have 2 raised over 3 raised to power 2. What will that give you? That's 2 raised to power 2 over 3 raised to power 2, and that is 4 over 9. Those are just those notes. Those notes will be very, very important when it comes to indices. Now, in summary of what I've been saying, you have a lot of indices for you to be able to run around, calculate some questions on indices. These 7 laws are very important, and the 2 notes. Now, once you're able to understand how you can run around these 7 laws, you will find indices, questions, simplifications on indices, on exponents, very, very easy. With it will be without stress. Now, for more example, check my next video, and I will drop a link below. I have a book on law of indices that on indices alone. It's an outline. Algebraic indices, 100 solved solutions. I have 100 solved solutions ranging from simple to complex. But in my next video, I will continue with more examples. Thank you.